So to just conclude this chapter, what were we trying to do really? It might seem overwhelming, we might seem to forget what exactly we're trying to do. We're just trying to do this. We had an example input text. We tokenized it by breaking it down into separate words like this. This is an example. Again, we when we use byte pair, it does it differently. But for illustration purposes, this is what is happening. It splits into words. That's tokenized text. And then we find their token IDs by looking up in a vocabulary. What what is what is the token ID for this? It is that. What is the token ID for is? It is that. What is the token ID for n? It is that. Token ID for example, it is that. Token ID for the dot, it is that. And after we do that, we then use our uh, embedding layer to convert these token IDs into embeddings, depending on the dimension that we want to that we want. Here we're just using 3 dimensions, but in the previous video we used 256 dimensions. So it pretty much just says in my embedding matrix, the matrix that has all the embeddings, where this index 40,134, I'm going to extract that row. I'm going to extract that row. That row is going to come with 256. In our case, it comes with 3, but it will come with 256, or it will come with embedding dimension numbers. So in our case, it will come with 3 numbers. And then we look up 2052, and it comes with those numbers, and so on and so on. We have now embedded our tokens. But we said embedding like that way is a problem, because if you have repeated um, tokens and it and similar problems, there's no notion of position. So let's create another layer of embeddings, which are going to say positional embeddings. And in our case, we used the absolute positional embeddings to say these positional embeddings are dependent on the position of the token itself. We created that one that we have the same dimension as our input text. As you can see here, as our input, as our token embeddings, I mean, the same dimension as the token embeddings. Here is 3, 3 is 3. And then we moved on to then add the 2. And now these are the input embeddings. Now our model, we are at this stage of the process. In the next video, we are now getting into the GPT model itself. And that's the sweet stuff. We are now going to see how attention mechanisms work. We're going to get into things like softmax calculations, matrix calculations. We're going to get into dropouts, all of those things. We are now getting deep into this. You remember that? That paper from Google where they were showing the attention mechanism, they are showing the transformer model. That's what we are going to get into in the next chapter. So I'm excited. I hope you are too. So see you there.